Now, if you're anything like me, you'll have plenty of equipment lying around your house that's really old, but you can't bring yourself to throw it out because it's working just fine. Now, one example of that is this TV that I've got in the bedroom. It works perfectly well, the picture is great and the sound is great. It is technically a smart TV, but it's got one flaw. It only has a wired network connection. It doesn't support wireless. So if I want to get it on my network, I'll have to run a network cable to it somehow. And I don't have any network ports or anything like that in the bedroom. So to work around this, I'll need some kind of adapter that can turn a wired network connection into a wireless network connection. I can do that with a Raspberry Pi. Let me show you how. Happy New Year, Pi geeks and techno nerds all around the world. My name's Jeff, and I'm an IT professional who's been in the industry for over 30 years. I've been using Raspberry Pi since they first came out, and I wanted to share with you some of the projects that I've done along the way. If you like what you see on this channel, do exactly what it says on my t-shirt. Hit that thumbs up button, subscribe if you want to see more, and hit that notification bell so you can be told when I put a new video out. Let me know in the comments how you get on with this project, and if you've got any ideas for other projects you'd like to see me do in the future, put those in there as well. Now, as I said in the intro, I want to get my old TV hooked into my network, but it only has a wired network connection. Now I can use a Raspberry Pi to kind of turn the wired network connection into a wireless one. The way I do this is by having the Raspberry Pi kind of act as its own little network server. So it will serve up different IP addresses to whatever devices I connect to it, compared to what I'd normally get out of my home router. The Pi then acts like a router itself, sending all of the network traffic between its wired and wireless network connections. And it's actually really easy to set this up. So let's go and take a look at what you need. Now, obviously, the first thing that you're going to need here is the Raspberry Pi itself. In this case, I'm using a Pi 02W just because it's a really small piece of kit that can tuck behind my TV really discreetly. Now, since I'm using a Pi 02W, I don't actually have an RJ45 socket on the Pi itself. To get around this, I'm using one of these USB network adapters. Now this is one that I actually bought ages ago, and so it only goes up to 100 megabits per second. Now in order to get my TV on the internet and have that working with all of the smart TV apps, that's absolutely fine. But just bear in mind, if you do need better performance, you can get USB network adapters that do go up to gigabit. So get what's right for you. Now the next thing you need is a micro SD card so you can run Raspberry Pi OS. In this case I got a 32GB one, but that's complete overkill. Even if you had a micro SD card as low as 4GB, that would be absolutely fine. Now in order to connect your Raspberry Pi to the device, you'll need what's called a crossover network cable. Now these are special network cables. If you just get a regular one, it won't work. With network cables, there are two standards for laying out the small pairs of wires that exist within the cable. The most common is the B standard that you can see on the bottom here, and that has the layout white, orange, orange, white, green, blue, green, white, brown, brown. If you take a look at any network cables that you have, with the clip side of the plug facing away from you, most likely that's the order that you'll see the wires arranged. Now there is also the A standard, and this has the green wires and the orange wires transposed. So it goes white, green, green, white, orange, blue, orange, white, brown, brown. Now if you had a network cable that had that kind of format at both ends, it would perform in exactly the same way as the B standard. And these kind of cables, where you have the same standard used at both ends, is called a straight network cable. A crossover cable has the A standard at one end and the B standard at the other. And what this really allows you to do is connect two devices without needing any kind of switch or hub in the middle. So in my case, I'll be able to connect my TV's network port directly to my Raspberry Pi's network port using the crossover cable. So now we've got all of our kit, we can start putting this project together. The first thing I've done here is I've used Raspberry Pi Imager to download the 64-bit light version of Raspberry Pi OS, and I've then taken the SD card, put it in the Raspberry Pi and booted from it. It's now sat there connected to my Wi-Fi network. If I run the IP address show command, you can see there are 3 network devices shown. The first is the virtual loopback device, the second is the wireless LAN, and that's connected to my home Wi-Fi with a 192.168.0.190 IP address. Now you can also see that my USB network adapter is working just fine. I've not had to install any drivers or go through any kind of work to get that detected. It just all worked automatically, and that's showing up as ETH0. I don't have a cable plugged into that right now, and that's why no address is showing up. As with any new Raspberry Pi installation, it's always recommended that the first thing you do is update all of the operating system packages. And you can do that with this command here, sudo apt update $sudo apt upgrade -y. It'll take a few minutes to complete this, so I'll just come back when it's finished. Now the OS is updated, but I also want to update the firmware on the Raspberry Pi. You can do that with the command sudo rpi-update. Strictly speaking, you don't need to do this, but I always think it's a nice idea to make sure that your Pi is entirely up to date. Again, it will take a little bit of time to run, so I'll just come back when it's finished. Now that's finished, and it's asking us to reboot the Raspberry Pi. There's one last thing I want to do before I reboot, and that's give the ETH0 interface a static IP address. Now, if you've been watching my channel for a while, you may remember that I created this video here talking about how to define a static IP address on your Raspberry Pi. Now, one thing that came in from the comments was that you could use a tool called NMTUI, which is a text-based menu interface into the Network Manager tool. Now, I wasn't aware of this when I made that video, but it's actually a really useful tool for doing this. Now, all of the methods that I put in that other video are absolutely still valid, but let me show you how you can use NMTUI to set a static IP address. You can start NMTUI just with this command, sudo NMTUI. And what we want to do here is we want to edit a connection. Here we're shown both our Ethernet connection, ETH0, and our Wi-Fi connection, WLAN 0. We want to work on the Ethernet connection. That's already selected, so I can just tab over and come down to edit. Now here I want to give the ETH0 interface a static IP address. Now my home network uses IP version 4, most likely yours does too. If you use IP version 6 on your home network, you'll need to give it an IPv6 address. That's kind of outside the scope of this video though. I'm only going to be talking about IPv4. So all I have to do is use my arrow keys to come down to IPv4 configuration, hit enter to change it, come down to manual, and tab over to where it says show. I then come down to the addresses section and hit add. And in my case, I'm going to give it the address 192.168.151.1. Now, since my Raspberry Pi is going to be the router for this network, I'm going to leave the gateway section blank. But I am going to come down to DNS servers, hit add, and I'm going to put in the IP address of my home network router. In my case, 192.168.0.1. And this is because in terms of internet connectivity, it's still my home network that I need to route through. So using my home network router as the DNS server still makes sense. After this, I can just come down to the bottom of the form and then hit enter on OK. I can then use the arrow keys to come across and down to back, and I can activate that network connection. Wired connection 1 is the default one that's selected, so I can just come over to the activate link and then hit enter. It won't be able to connect to anything right now, again, because I don't have a network cable attached. But if I hit back and I come down to quit, if I run the IP add show command, now you can see the ETH0 interface now has the IP address 192.168.151.1. Now we've got that set up, I'm going to reboot the Pi. Now the Pi is rebooted, there's a couple of extra packages that we need to install for this project to work. So I'm going to install DNSMasq and IPTables. DNSMasq is basically going to allow our Raspberry Pi to act as a DHCP server on that new 192.168.151 network. IPTables is a firewall software at heart, but it's really cool in that it also allows us to implement some routing functionality, and this will let us make all of the network traffic flow between the wired and wireless network connections. So I'm just going to install these two packages with sudo apt install -y DNSMasq IPTables. The next thing we need to do is set up DNSMasq as the DHCP server. To do this, we need to edit its config file. I'm going to use Vi to edit this, but if you'd rather use Nano, be my guest. I'm just going to come all the way to the bottom of the file, and I'm going to add the block of configuration that you can see here. Now, the most important pieces of this are specifying that the DHCP server will be listening on the ETH0 device, and it will be able to serve out addresses starting at 192.168.151.50 and going all the way up to 192.168.151.150. Now, since I'm going to be using a crossover cable for the connection, I could have limited this to one single address if I really wanted to, but there's no harm in putting in a range. The 12H says that any address allocation will last for 12 hours. After this time, the device should re-request an address again. It could then serve out a different address, but most DHCP servers, including this one, will continue to serve out the same address to a device unless everything is entirely reinitialized again. Once you've got this configuration in place, all you've got to do is save the file. And then we want to restart the DNSMasq service with the command sudo systemctl restart DNSMasq. We can then check that the service is running okay with the command sudo systemctl status DNSMasq. And there you can see it says it's running. The next thing we need to do is set up the routing rules using IPTables. Now, it's always advisable with IPTables when you're setting up rules that you clear out anything that was there previously, just to make sure that you don't end up with any rules that conflict with each other. And you can do that with the command sudo IPTables -F $& sudo IPTables -T nat -F. The next thing I want to do is set up address translation between my internal private network, the 192.168.151 network, and the external network, in this case my 192.168.0 network. And this is on the WLAN 0 interface. I can just do that with this command here. Sudo IPTables -T nat -A POSTROUTING -O WLAN 0, which is the network interface that my home network is connected to, -J MASQUERADE. Then I want to set up the rule that says that anything that appears on WLAN 0, I want to forward to the ETH0 interface. I can do that with this command here, sudo IPTables -A forward -I WLAN 0, i.e. my home network, -O ETH0, my private network, -M state, -- state related, established, -J accept. Finally, I want to put the reciprocal rule in place that says that anything on my private network I want to send back to my home network. And this is done with sudo IPTables -A forward -I ETH0, my private network, -O WLAN 0, my home network, -J accept. Now, one gotcha with IPTables is that by default, it doesn't make any of these rules persistent. So if you rebooted your Raspberry Pi, you'd lose all of these rules. I'm then going to save them by running the command sudo --c, which just spawns up a new shell, and then runs this command IPTables-save, redirect the output into /etc/IPTables/rules.v4. Now that command that I have to run now, I also have to put in single quotes. Now the rules are saved, I also have to make the Raspberry Pi read those rules and apply them whenever it boots. And I can make it do that by editing this file /etc/rc.local. Now by default this file won't exist, so when I go to edit it here, it's creating it for the first time. All I'm going to put in here is #!bin/bash to say what shell it should run this script as, and then I'm going to add this line /usr/sbin/iptables-restore, and then redirect into that our saved file /etc/iptables/rules.v4, and then just save that out. And then I need to make that file executable with the command sudo chmod +x/etc/rc.local. The last bit of configuration I need to set up here is to enable IP forwarding within the Raspberry Pi network configuration. And I'm going to do that using this funky command here. Sed is a command line text editor. The -i option means that I want to actually make my changes to the file. By default, if you run sed, it will give you the updated file as output, and then you'd need to redirect that to a separate file and rename it. By using the -i option, you can just have those changes applied directly. Then within single quotes, we specify the rules of what we're trying to do. The S means that we want to do a substitution, and we then have a pair of text strings that are separated by /. The first string here, #net.ipv4.ip_forward=1, is what we want to replace. The second string, net.ip_forward=1, is what we want to replace it with. So what you can see here is all we're doing is removing that leading hash character. We then put a G option on the end to make it do a global replace. After this, I just need to specify the name of the file that we want to update. In this case, /etc/sysctl.conf. And we can check to make sure that our change has taken effect by running the command sudo sysctl-p. And there you can see we've got our setting. And now, once again, I just need to reboot. Now we're rebooted, I can prove that the IPTables configuration is still in place by running the command sudo IPTables-s. And there you can see that all of our rules have been persisted. I can also double check that we're still configured as a routing node by running once again sudo sysctl-p, and you can see that we're still set up as a routing node. So now we're ready to connect a device and prove that it all works. Now my TV doesn't have the best interface on it, and so it's a bit tricky to show you exactly what's going on under the hood if I connect it to my Pi Zero. So in order to be able to show you how this all works, I'm actually going to demo this using another Raspberry Pi. I'm going to have a Raspberry Pi 4 set up with no Wi-Fi connection. And then I'll connect it using a network cable to my Pi Zero so you can see how it gets an IP address. So on my Pi 4 here, if I try to ping google.com, it won't work because I've got absolutely no internet connectivity whatsoever. Indeed, there is no network connected to this Pi at all. If I run the ip-add-show command, you can see there are no IP addresses configured, nothing for ETH0 and nothing for WLAN 0. So now let's see what happens when I plug in the network crossover cable from my Pi Zero. Now you can see that the Ethernet interface has started up okay, and it's been allocated an IP address by the Pi Zero. If I run ip-add-show again, you can see that we've been given the IP address 192.168.151.67. And indeed, what's more, if I ping google.com now, you can see it actually works. So all of the internet connectivity is coming from the Pi 4 down through the crossover cable to the Pi Zero. The Pi Zero is then routing all of this traffic to its wireless adapter and onward to my home network and ultimately out to the internet. So now I should be able to take all of this, connect it to my TV and see that connecting to the internet. Here you can see my TV running, and I can now do internet-based things like bringing up a browser and searching around on Google, and also bringing up YouTube and watching videos on there. So there you go. I've brought another old piece of technology back to life again thanks to a Raspberry Pi. Now there are plenty of old devices out there that only have physical wired network connections available to them. So if you have one, you can use techniques as I've gone through in this video to allow them to connect to your Wi-Fi network and get a whole new lease of life. But that's it for this video. Once again, if you like what you see here, please hit that thumbs up button, subscribe if you want to see more, and hit that notification bell so you can be told when I put a new video out. Let me know in the comments how you get on with this project and about any devices that you're able to get connected onto your Wi-Fi network that you otherwise weren't able to. And again, if you've got any ideas for other projects that you'd like to see me do on the channel, let me know in there as well. Thanks so much for watching till the end, and until next time, bye for now.